Like my nephew Jacob, he was freaking playing the game before it was ever freaking put out because they gave you offers to where you could play it before it was released, and
Yeah,
that's
yeah,
how they would come up with these games, and that's how they're doing it now, and they don't realize that that's just producing like shit games. You know what I mean? And I've got my
yeah.
hope.
If I remember rightly, I in relation to possibly Mind's Chateau, the new version of Mind's Chateau. In the Mind's Canaries chat room, I was talking about. I pointed out to Bill that I was not a big fan. I'm not a big fan of. I think it was Tan actually. I'm not a big fan of the sort of early release concept being pushed onto regular consumers.
Right.
And I point out that we've seen this a lot in the gaming sort of mark industry, where um, publishers will release these games before they're really being fully both tested and fully developed, and we'll expect people to pay full price for these games. And in most cases, you will see patches and improvements being rolled out over a period of time. But in other cases, um, you will see that once released in whatever state it is, that's the end of the project for these publishers.
I want to start discussing the tensor cores, which are specialized processing units within NVIDIA's GPUs. They're designed to accelerate the performance of machine learning and AI workloads. That's what the key functions of them are. They're also a key feature in NVIDIA's Volta, Turing, and Ampere architectures. And I also believe Beyond as well, and Beyond. Now, it's specifically aimed at improving tasks that involve like tensor operations, and that's specifically what it's aimed for. It's supposed to improve tasks that involve it. Um, Now, the essential part of the deep learning and artificial intelligence computations has to do with these architectures. So that's kind of what it's all about. Now, tensor cores were introduced with NVIDIA's Volta architecture in 2017, and since then, it's been incorporated into their RTX series of graphics cards. That includes RTX 20, 30, and 40 series. These cores, they also do play a crucial role in AI-driven applications, such as like deep learning super samples, which we had already discussed, the DLSS, and also something else that I had mentioned too that my son really likes is the ray tracing, the real-time ray tracing. That's something that tensor cores are really, really important for. So that is something to think about as well. So um, besides that, you also have to understand that these cores are are also used in various scientific computations and stuff of that nature too, not just in gaming and everything of that nature. So, with all that being said, I guess it's a good time to explain exactly what tensor cores are. Okay, now I can do that in simple terms. Tensor cores are hardware components that perform tensor processing. This involves multi-dimensional data arrays and it's used extensively in deep learning algorithms, basically. Now, these cores optimize. They're optimized basically to like handle large volumes of data within complex mathematical operations, and they do it efficiently. Um, it makes them more capable of handling AI tasks than what traditional CUDA cores uh, are capable of handling. When I say that, that's the general purpose processing units that are in NVIDIA's GPUs. Now, a tensor is a mathematical object that generalizes scalars, vectors, and matrix to higher dimensions. Deep learning, for instance, relies on these high dimensional arrays to represent complex data sets like images, sounds, and text. Tensor cores are designed to accelerate matrix sounds and text. Um, uh, Actually, the best way of saying it is tensor cores are designed to accelerate matrix multiplications and convolutions, I guess you could say. Um, and this is actually fundamental operations in like neural networking and training and inference and stuff of that nature. Now, how do tensor cores work? That's another thing that I can answer to. Now, tensor cores use a specific type of matrix multiplication called mixed precision matrix multiplication. All right, this allows the combination of different levels of precision during calculation, which enhances performance without significantly compromising accuracy. Now, uh, here's how tensor cores are designed to handle these operations. First, you have the mixed precision computing, and that is where tensor cores are optimized for mixed precision calculations, typically using half precision, which is FP16, for the input, and signal precision. That would be FP32 for the output. Now, by using lower precision in the input, tensor cores can process more data in parallel, resulting in faster performance and greater throughput without a significant loss of accuracy. Now, this mixed precision approach is highly beneficial to AI, where the loss of precision doesn't impact the quality of the result. Now, after that, there's also matrix multiplication. Now, matrix multiplication is a significant part of deep learning, which involves multiplying matrices and process used in operations like convolutions, that fully connected layers, and processes used in operations like back propagation, things like that. So tensor cores are specifically designed to perform matrix multiplications, all right, at high speed, making them much more efficient for training deep learning models compared to traditional GPU cores. Now, I've mentioned high throughput quite a few times, so this is something too that I need to bring up. Now, tensor cores achieve their speed by processing multiple calculations simultaneously in parallel. All right. This high throughput is essentially beneficial for large data sets which deep learning models process vast amount of data at once. Um, the more operations tensor cores can handle in parallel, the faster the AI model can be trained or used for inference. That brings us to deep learning operations. Okay, now tensor cores are used for operations in both training and inference of deep learning models. Training a model requires many interactions of matrix operations to adjust the model's weight, and inference uses trained models to make predictions on new data. Tensor cores are optimized to handle both types of workloads efficiently. Um, this makes them invaluable for AI developers and researchers too. So, just so you know. Now, after that, I want to also say what the role of tensor cores in gaming and AI is. Um, Tensor cores have basically found a wide application in several advanced gaming technologies, especially in real-time rendering and AI-powered features. Um, there's some key areas where tensor cores are used, and that would be the DLSS, which is deep learning supersampling, which I've discussed in the previous episode. Um, this is one of the most popular applications in tensor cores, uh, and that DLSS is what I'm referring to. And that's where the cores are used to upscale lower resolution images in real time. That allows the game to run at higher frame rates without sacrificing image quality. The tensor cores process the AI models that reconstruct high quality frames from lower resolution ones. So that's where it's bouncing from uh, uh, lower resolution to higher resolution, and then frame rates and all that. So you've got all that going on. Then after that, you have ray tracing, and that's where tensor coils are used in real time as well. Ray tracing with ray tracing technologies, um, they accelerate the computation of light, shadows, and reflections in 3D environments. This leads to more realistic visuals in supported games. Now, while ray tracing is a demanding task, tensor cores do help offset some of the performance impacts by accelerating certain calculations involved in the ray tracing process. And it is true, ray tracing does cause a lot of. Well, I know from like a CPU, I know that when you use ray tracing, it does exert a lot of a lot of I don't even know how to say that. It exerts a lot of energy from your computer, basically. Causes a lot of stress on your computer. So that's basically what that's about. Now, after that, AI and machine learning and gaming is also something that tensor coils are used for. Tensor coils enable AI-driven gameplay mechanics in video games. Um, and for example, there's smart NPCs, non-player characters, dynamic game environments, and adaptive difficult levels, things of that nature. Games can use AI to adjust elements of the gameplay in real time, which is supposed to make the experience more immersive and challenging. After that, you have enhanced AI features. Many modern games use AI to improve procedural generation, which I already went through that procedural generation and procedural algorithms. Uh,